おはようございます。今日の朝のHoudini作業配信を始めていきたいと思います。今日は前からちょっと気になっていたチュートリアルがあるので、それをやっていきたいなと思っています。はい、では始めていきます。
Hi there, it's Dima, and today I will show you how to create this roots or vine system, which is fully procedural, very flexible and very fast, and can be applied to any geometry. We will use a lot of VX coding and some for loop systems, and I will explain every step. At the end of the video I will show you how to render this in Redshift. Let's start. So let's create a geometry node. Dive in. Let's create a grid and append the remesh.
ちなみにHoudiniのバージョンは 18.5 です。このチュートリアルはどうやら HDA 化されているようなんですが、それだとバージョン 17.5 なんですけど、あんまり古すぎるのでやるのもあれなので、基本18.5 以下は使わない予定です。17.5 だとフルヘドとかすげえ変わってんだっけ。はい。なので、今回は 18.5 で進めていきます。はい。
Let's append the color for better visibility. Okay, so what do we want to do? So, how the root system works? We can use a find shortestpath. We can define some start point and
ちょっとファインドショートエスパスの説明をしているので、ちょっとそっち移してみるか。
we can define some endpoints, and then the system will automatically create the roots using the shortest path and the edges of the geometry. The only problem is how to set this start and end points, because to do it manually is too long and ineffective, and to do it procedurally so you can face some problems. So I will show. So let's start with a skater node. Let's say that we will have 3 points. Let's group these points as start points, and let's now copy them.
グループして、エンドかな。
And the second skater will be with a lot more points, and the second group will be with a lot more points. And the second group will be the end group. Let's merge them together.
マージは複数選択をした状態でオルトをしながらやると簡単に作れます。
And now we'll append find shortest path, and this point goes to the second input, and here
あとコントロールシフト、シフト S で、このネットワークの形状を切り替えたりできます。
start points are start and end points are end. The mode from any start to each end. And what we have this beautiful system, but there are some problems.
スタートと1エンドかな。スタートから1エンドかな。これだとすげえ綺麗だ。
These problems are that we don't have intersections between the root systems, which is beautiful, but that's not what we desire. So we can change the first scatter to create some procedural patterns. This looks good, but I want it to be more different. I want some of these patterns to be more long or more short. I want to get more variations out of this, and I don't want to do this manually at the same time. I want it to be a fully procedural system. That's why we created manually. Let's start. Okay, let's start with
もう一個か。
the for each loop with feedback. This nodes allow the for each loop with
ループか。
feedback. This node allows you to create an action which will repeat as many times as we need. This node allows you to create an action which will repeat as many times as we need. In this case, 10 iterations. Let's start with 1. So first, what I need is to get the full amount of points on our geometry. So we have here around 5,000 points. So let's geometry. So we have here
数が少ない。全然少ない。ちょっと待って。メッシュでこっちにしろ。 あ、そっか。違う違う違う。サイズでかくしてんのか、もしかして。最初の方ちゃんと見てなかったな。これ戻るか。
Let's
でも何もいじってなかった気がする。で、超点数違うんだ。変わらんな。サイズは変えてない。あ、リメッシュのバージョンが違うせいか。ああ、リメッシュのバージョンが違うせいだ。なるほど。うん。引っ張られる。結構ポイント数変わるな。なるほど。
on our geometry. So we have here around 5000 points. So let's get them in the attribute. We want to do this before loop. Because we are going to change our geometry and therefore the amount of points inside of this loop. Therefore we need to do this before loop. Let's name it PT amount. So PT amount. And let's create an integer attribute PT amount, which is numpt. And let's execute it, run over detail only once. So now in the geometry spreadsheet we can see
ポイント。頂点数を確保したいのね、ディティールに。
in the detail mode that we have this PT amount attribute, which is equal 5000. Let's go inside of the repeat block and append a point wrangle. Let's name it asset set scatter. And what do I want to do first here? I want to initiate some groups. Let's create a group start, which is 0 by default. Let's create a group end, which is also 0 by default.
文字が小さいね。
Oh,
スタート。
I want to get this pt amount inside of this scatter node, just to be sure that it's here. So let's create an integer attribute pt amount, and this attribute is detail because our attribute is detail. We read it from the 0 input, which is default input, and our attribute is pt amount, and the float value is 0 because this attribute is a float attribute. Now I want to get a number of the current iteration. The current iteration is 1, but there will be more in future. So how we can get these iterations? We can copy this node with creating a meta import node, and inside of this node we have the extra attribute iteration. We can connect this node with the second input of the attribute wrangle, and now we can create an integer attribute iteration, which is again detail. Now we read this attribute from the input 1, which is second input here. The attribute is iteration, and the float value is again 0. Now let's see how many points we want to make first. Let's say I want each iteration to create, say, 5 points. So I want randomly select 5 points on the geometry, and I want to select them each iteration. So let's define this amount as amount is integer channel amount. Let's press this button, and now we can select this amount, for example 5 in this case. And now we want so for example, this point have this number, this point has this number, this point this and this. So we have these 5 numbers, and we want to get them randomly based on the current iteration. How we can do this? So first we need to execute
ポイントの全体数とループ回数とランダム抽出するポイント数か。
some randomized system as many times as we have so how many points we have selected. So in this case 5 points. So we will use the for statement for this case. So let's define some integer attribute which is 0 by default, and let's say that the statement will execute until the integer attribute is less than our amount attribute, which is 5 for this case. And let's now say that this attribute at the end of each iteration is incremented by 1. Now we are sure that this statement will execute 5 times because we have the amount of 5 here. So what we can do this here? So we can define our IDs. Let's create an integer attribute ID start, and let's use a randomize function based on the current iteration number, which we store here. And let's add some extra randomness with a float channel start seed. If we want manually change the randomize of the system in future, let us also use the extra randomize based on the current sub-iteration number, which is integer number, and let's multiply them, because it's the value of this iteration number is too slow or is too low, so from 0 to 5, so let's increase it by multiplying it by 500, for example. So now we have this randomized system. It gives us the value from 0 to 1, but we want the values to be from 0 to 5000, so let's multiply them by our PT amount, which is 5000 exactly, PT amount. So now we have this randomized number based on the current iteration and the current sub-iteration, and the numbers lay between 0 and 5000, and the only problem is that we need an integer attribute, and this attribute is float. So let's round it down with a floor function. So now everything is okay. So now I want to create a corresponding points.
腰が痛いな。ちょっと待って、01で0から1の与えてランダムに出してから全体の頂点数かけてフロアで切り捨て。
So for each start point I want to create a corresponding point somewhere else on the geometry. So 1, 2, 3, 4, 5, because I want to use them as a direction. So we want to use these points as directions for our root system. So the root will grow. So roots will grow in this direction in the future. So let's define these random points, and with randomizing their positions, we can change the direction of our roots growing. So let's copy this id start attribute variable actually. So and let's name it id end, and what we need is only to change this start seed to end seed. Let's press this button to append our start and end seed. We have to change end seed. Let's now check if everything is okay. We can check it. So we create an integer attribute id start, which is id start, and we create an integer attribute id end, which is id end variable. And let's check in geometry spreadsheet. We have this id end and id start attribute. So actually that's not
スタート、エンド入ってるね。
true, because actually we have so every point now has 5 variables from so 5 random variables from 0 to 5000, but we can see only last of them, because the very last, because in other case we will need an array, but I don't want to make an array right now, just for debugging, and that's enough. We just must be sure that these numbers are different, and they are different, so we can change it with the start and end seeds. So everything is okay. The numbers are different. So let's leave it as it is. Let's get rid of these unnecessary attributes. So now let's clean a little. Now what we have all these points. Each of these points has the 5 numbers, the 5 random numbers of these attributes, but we want to only those points be processed which attribute is equal, so those points that have the same number as the attribute ID start. So for example, if the point has a certain number, so for example this number, so and the attribute has ID start has the same number, we want this point to be processed. So let's do this with the if statement. If the currently processing point is ptnum, if ptnum is ID start, so double equal, then we will process this point. What do we need here? First we need to set point group. We want this point to be in start group. The point is ptnum. We are adding this point to the group, therefore it's the 1 value, and the mode is set in this case, because we are overriding any existing values. Now, what we want to do now? Now I think it's time to visualize our start points. Let's just do it by this. So we assign a color to these points, and we can see that we have 5 points. If we change the total amount of points, we will have more points. If we change, if we change the start seed, we change the position of these points. The end seed doesn't affect anything because it's only the start points here. So now what we want here, we want to define, we want to read the position of the corresponding points. How we can do this? We can do this with a vector variable. Vector variable end position is point. We read this position from the 0 input. The attribute is position, and the number of point is ID end, which we assigned here. So we have these positions here. What we want now, we want to make a vector between each two pairs. So we can make this vector by subtracting values one from another. So let's make a vector which is direction, dir, which is our current position minus end position. And because this is a direction, we want to normalize this. Normalize. So to be sure that the vector has a length 1, and now we has actually this vector, because when we have P1 and P2, and we subtracting from this to this direction, so we have the inverted vector. So now we want to invert this vector. Let's just put down a minus. So that's what we have right now. We have this vector between every 2 points, 2 corresponding points. So let's now define the length of this vector, because I want to change the length procedurally. Long length is we can create a float channel. Let's name it basic length and put down this slider. So basic length is 0 by default, which is okay for now. What do I need now? So let's say we have this. So let's create new picture. So we have, for example, this number here, and we have, for example, this corresponding number here. So we have this direction vector with a changed length, and I want to get the end of this vector. I want to find the closest point on the geometry, the closest to this vector, and to use this as a base for scatter points around this point. And then I can create the routes in this direction based on the start points, start and end points. So let's start with the end of this vector, with this point. So how we can get this end? Vector final end is our current position plus our direction multiplied with length. This is a final end, and let's now find the closest point on the geometry. And PT is near point based on the final end. So now we have some point on the geometry which has a certain number which is closest to this end of this vector. Okay, all we need to do now is to set point group of this new point as a scatter. So this point is end PT, mode is set. Okay, now as you can see, if we middle click here, we have 5 start points and 5 scatter points. Let's create some scatter. Let's create this copy. If we middle click here,
レングス0だったら、その頂点座標になるから、5個しかなさそうだけどな。なんでだ。ポイントで取ってきて。 でだろ
Okay, now as you can see, if we middle click here, we have 5 start points.
1329。どっかでミスってそう。書き合いとして。ストート。何が間違いないのこれ。つってんのか。ああ、そっか。との一致するポイントでやってないからか。そりゃそうか。ちょっと待って、でもリアの参照が外れるか。全部この中でやんなきゃダメじゃん。そりゃそうか。
points and 5 scatter points. Let's create some scatter. Let's create this copy to points. We can, inside of this copy to points, use target points and let
これも新しいからな。
let's type scatter points here. Scatter points here, and let's create some scatter spheres.
ああ、そうか。そういうことね。残されるアトリビュートが全然違うのか。だいぶ、そっか、こういうこともなくなっちゃったから表記が変わっちゃうんだな。 同じだけど。マルチプライがあるのでほとんど同じだな。まあ、一旦バージョン下げてやってみるか。
Let's merge them with the scatter geometry. Okay, now we see these spheres, and now we want to use these spheres. So we have these spheres here. Now we want to use them as a base for scattering points around. Let's start this with scatter. The problem is we have the certainly visible surface. I don't want this surface here, therefore we can use some method to get rid of these points. For example, we can use VDB from polygons in the density mode, but I wouldn't prefer this method because it can be very slow when you have a large scale. So as you can see, now we have the points inside the spheres, but this method can be very slow, so I would not prefer to use this method. We could use a jitter points, point jitter soap. In this case it's better, but we also have a problem that we have an initial radius of the spheres, which is 1 by default, and if I set it to 0 because I don't want it to be 1, and then if I set it to 0 because I don't want it to be 1, and then we increase the scale of the jitter node, that you can see that they are no more spheres but they are cubes, which is
同じポイントからスタートするかってこと。
maybe a bug of the point jitter. So instead of use this point jitter, I would prefer to create our own jitter. Let's say jitter. So it's not difficult. Let's just do this. Let's define a random vector for every point. We can do this with a sample direction uniform. It gives us a random vector based on the any float number, which we can use, for example, random based on the pt num. And let's define a float random length of this pushment of the points. So let's create another random system based on the ptnum plus some extra values for the extra randomness, and let's push our points by adding this direction vector multiplied with a random vector, with a random value, I mean. So now we can see that they are spheres again, which is better. So let's group
ディレクションユニフォーム。なんか適当なベクトルを返してくれる関数なのかな。で、シードをかけて、
let's group them together. This group will be n. Endpoints. Now let's create a find shortest path node. Find Now let's create a find shortest path node. Finally, and let's append it to the very initial geometry, and here we have our start and end points. Let's connect this to the second input of the find shortest path.
ここでばらまいたのをエンドにして、スタートをランダムに作ったここでしょ。バラバラのものに対してショーテストパスをかまそうとしてるってこと。
Let's say that the start points are start and end points are end, and the mode is from any start to each end. Here we have our 5 systems. So the only problem
でも結局パスがないから、平面にしかならない。
if we change the iteration number, we will see nothing, because every iteration, the first node in this block will get the geometry from the last block, and if we change the geometry that way that we will delete the original geometry, it doesn't know what to do in this first block anymore. So therefore we don't want to delete the initial geometry completely. Instead we want to merge them before going to the end, and now we can increase the iterations.
いや、待って。デフォルトのやつをこれマージしないと意味ないのか。こいつをマージしたいってことか。配線がややこしすぎんな。ああ、そっか。最初の時点のものに対して、待って、これじゃダメなのか。する前に対してやんなきゃいけない。する前か、これ。あれ、ちょっと待って、わからなくなってきた。100回だ。ちょっと待ってよ。
To delete the initial geometry completely. Instead, we will want to merge them before
パスして、これ戻しちゃうと消えてしまうか。この時点では、それなんだよ。線がぐちゃぐちゃしててよくわからなくなってきたな。ベースのジオメトリとスキャッターしたものでマージしてんだ。で、それを使ってファインドショーテストパスで、これをデフォルトのジオメトリとマージしたいんだが、消えちゃうんだ。そうだ。なんでキープオリジンジオメトリーが関係ない。じゃあこれは残るだけだ。ここをマージしてると消えちゃうのはなんでだ。 回見直そう。ちょっとわからんくなってきたと。そもそもですけど、あそこ、そんな状態から取ってこなきゃいけないのか。ことか。いや、消えてまんな。これわかんねえ。ちょっと待って。イテレーションカウントを増やしても消えないようにしたいんだよ。これじゃね、マーチイテレーションにしなきゃダメなんじゃなかったっけ。違ったっけ。
Anymore. So therefore we don't want to know what to do in this first block anymore. So therefore we don't want to delete the initial geometry completely. Instead we delete the initial geometry completely.
これマーチイテレーションにしなきゃダメなんじゃなかったっけ。
Instead we want to merge them before go
これやっぱできねえな。なんでだ。わかんないぞ。これはちょっと無理か。
point to the end and
結果が来ない。これはなんでだ。やばい、マジでわからん。これで
instead we want to merge them before
これむずいな。待って待って。テストして。ここで消 消えちゃう理由がわからんな。今にしてせいだと思うけど。なんか設定間違えてるか。苦手なんだよな。
Going to the end, and now we can increase the iterations.
前のやつが残らないんだよな。これなんでだ。レジスト、スタートポイント&エンドポイント。あれ待って待って待って。2回目でグループが消えてんな。以降のグループが消えてる。これは関係ない。なんでだ。待てよ。ここでエンドスタートがあるよね。とか言って。あそこ。ここいなくていいのか。引き継がれる時点で。まずエンドスタートちゃんといるな。スタート。関係ない。ノーパス、ピトンスタートポイントと。パスが存在しない。とエンドの間にパスが存在しない。パスで、 トのパスからテストパスでないって言ってたから使ってんの。これがなんだ。ミスマッチ CD あ CD がない。いや関係ないよな。ここで CD が取るけどあるよ。ここで CD 取るけどなくなるの。でコストキーボードに順当にすると残るんか。キーボードに順当にすると残るんか。パスの計算できなくなるし、これ入れると。ここで CD が消えちゃうから、こことマージがうまくいかないから CD が出てないってわけではないけど。これは、ちょっと待って。だいぶだってんな。
As you can see now,
なんでだろう。ほんとわかんねえ、これ。なんでだ。ポイントに来てんだよな。ここでマッチしちゃうと消えるんだ。 そうなんだよな。この棒しか戻ってこないから。どんどん増えていくだけど。なんでこれマージすると消えちゃうんだ。マジでわからん。フォーループ苦手なんだよ。絶対違うもんな。この辺とかも。やばい。これは本当にわからん。なんだ。ちょっと行き詰まってしまったので、このままやってても下りそうなので、ちょっと今日のところはこれで配信を終わろうと思います。ちょっと改めて見返して、またやってみようかなと。なんでだろうな。全然わからん理由が。ちょっと自分がフォーループが苦手なので、なんか使い方が間違ってるんだと思うんですが、ここで回りして消えちゃうのがなんでなのかがわかんねえんだよな。まあ順番とか関係ないよな。当たり前だよな。なんでこれとこれマージしたら消えるんだ。マジで理解できん。これはわからん。本気でわからんな。というわけで、ちょっと今日は、なんか、だいぶ頭が凝り固まっている気がするので、整理するか、このゴミを。こうなるはずなんだよな。ここでマージがうまくいかない理由が本当にわからん。 CD コストミスマッチ。CD とコストとオリジンポイントがないって言ってるでしょ。これ外したところで関係ねえ。まだミスマッチがあるな。CD もないのか。あれ逆になんでこいつに CD アトリビュートがないんだ。まあマッチさせたところで変わんないよね。いや、これほんとわからん。マジで全然わからん。なんだこれ。ちょっと一旦今日のところは無念ですが、ちょっと配信を終了します。ありがとうございました。